Hello, and a very warm welcome to Kognito Key. Ever wondered how your computer can edit a video, play a game, and stream music all at the same time without, completely freaking out? Well, it's all thanks to a really clever idea called parallel processing.
I mean, let's be honest. We all want the same thing from our tech, right? We want it to be faster, more efficient, and just more. This constant hunger for speed is really what pushes all the amazing innovation in the world of computers. So that brings up a pretty logical question. If we just want more speed, why not build one single, ridiculously fast processor? It seems simple enough, but it turns out there's a much, much smarter way to get the job done. And it's all about teamwork.
Okay, so this is the solution. It's called parallel processing. Now, the main idea is actually quite simple, but so powerful. Instead of having one worker or processor do a huge task from start to finish, you break that task into smaller pieces and give those pieces to a whole team of processors to work on at the same time.
To really get a feel for this, let's use a little analogy. Just imagine a company that's trying to grow. So a single processor, that's kind of like a one-man company. That one person has to do everything, one task after another. It's slow, it's sequential, and there's a hard limit on how much work they can take on. But parallel processing, that's like hiring a whole team. All of a sudden, you've got multiple people working on different things all at once. The work gets spread out, the whole job gets finished way faster, and the company can handle a lot more business.
Of course, you can't just throw a bunch of processors into a box and hope for the best. This team needs a special kind of office, a specific hardware setup that lets them all communicate and work together without getting in each other's way.
And there are really three main ways to build this hardware office. Think of them as three different office layouts for our processor team. You've got bus-based, switched memory access, and hypercubes. Each one has its own way of handling all the chatter. First up, we have the bus-based system. Just picture all the processors sharing one single highway. That's the bus, to get to the company's main library, which is the shared memory. Now, if everyone was on this one road all the time, you'd have a massive traffic jam, right? To fix this, each processor gets its own little notepad, a cache memory. This way, they only use the main highway when they absolutely have to, and that keeps everything moving along nicely. Next, we have switched memory access. Here, the main memory is divided into different sections. Now, any processor can get to any section, but here's the catch. If processor 1 is using memory block 1 and processor 2 tries to grab it at the same time, it gets a busy signal. It just has to wait until that block is free. But in the meantime, it's totally free to go and access any other available block, like memory block 2. And finally, there's the hypercube. And this approach is totally different. Instead of everyone sharing a central space, here each processor is basically its own little computer with its own private memory. They're all connected directly to their neighbors, creating this super powerful, self-sufficient network. It's like a bunch of interconnected mini offices. Okay, so having the hardware, the office space is one thing, but any good team needs a manager, right? A boss to hand out tasks and make sure everything is running smoothly. In a computer, that boss is the operating system. And just like in the real world, there are different management styles for this OS boss. Having a separate OS is like giving every single employee their own manager. It's just not efficient. A master-slave system has one big boss telling everyone else what to do. But if that one boss fails, the whole company shuts down. That's why the most common way today is a symmetric OS, where every processor is like a co-manager, sharing the work equally. It's super efficient, but as you can probably guess, it is very, very complex to coordinate. So after hearing about all this complexity, you might be wondering, why go through all this trouble? Well, the answer is that the benefits, the payoff, is absolutely huge. First of all, you get a massive increase in something called throughput. It's simple, really. More workers, or processors, means more work gets done in the same amount of time. This is exactly why a complex 3D animation that used to take days to render can now be done in just minutes. Second, you get fault tolerance. In our one-man company, if that one person gets sick, all the work stops. But with a team, if one processor fails, its job can just be handed off to another one. And this is so important for systems that absolutely cannot fail, like for banking or for air traffic control. Third is scalability. What if you need more power? Well, you just add more people to the team. As our computing needs for things like AI research just keep growing, we can simply add more processors to the system instead of having to build a new one from scratch. It's incredibly flexible. And finally, believe it or not, it can actually be cheaper. Trying to build one single, custom-made super processor is crazy expensive. It's usually a lot more cost-effective to just link together lots of standard, mass-produced processors to get the same or even better performance.
So, what's the big takeaway here? Well, parallel processing is all about teamwork. It's about dividing big jobs into small pieces and using a team of tightly connected processors, all sharing resources, to get things done incredibly fast. And the real magic? All of this complexity is totally hidden from you. To you, it just feels like you're using one single, unbelievably powerful machine.
So the next time you're multitasking on your computer and everything is running perfectly smooth, just take a moment to appreciate the silent, amazing teamwork happening inside your device. If you found this helpful, we would love it if you subscribe to Kognito Key. And please do like and share this video. Thanks so much for watching.